Welcome to today's brief demonstration of the Lavastorm Analytics Engine. Today I'll be talking about the advantages of using the Lavastorm Analytics Engine over traditional databases and spreadsheets for your analytic challenges. Briefly before I start, I just want to run through a few of those key advantages that we'll see in the demonstration. So before I start, I just want to highlight some of the key advantages of the Lavastorm Analytics Engine. And these are things to look for in the demonstration. The first is that the Lavastorm Analytics Engine has a visual approach to creating analytic applications, as opposed to a scripting-based approach. This means that there are powerful pre-built analytic building blocks, or controls, that have analytic logic built into them. And these accelerators make it much faster for me to develop analytic applications and conduct analytic tasks. The second is that the visual model itself, which is constructed by these building blocks or controls, provides significantly greater visibility into the overall analytic application. So instead of wading through SQL scripts to find a place to modify your analytic application over time or debug it, the visual model provides an easy way to grasp the analytic application, the logic that's taking place, and to pinpoint where you want to make changes and pull off additional data. So this model reduces the scripting that's required. It exposes information so that you can improve data quality and results. And it makes it possible for you to capture, even package up analytic functions and reuse them in future applications. And finally, the advantage of the Lavastorm Analytics Engine is the speed and flexibility that it provides for discovery or ad hoc analytics. You can bring in data very quickly, much more quickly than you could if you were using traditional databases, and change the model just as quickly. And that means that you can adapt to changes in your business and can answer unanticipated questions in greater speed than ever before. And we have had customers that have tested this and have been able to create applications in just 1/10 of the time it would have taken with traditional tools. And finally, it's very easy to bring that data together because of the fact that the Lavastorm Analytics Engine does not require you to develop an overarching data model of every data source. And because you don't really deal with table structures like you do in traditional databases. So you're dealing right with the data. So there's much less overhead and much less time prepping before you actually start thinking about the analytic challenge in front of you. So we'll take a look at all of these things as we go through the demonstration today. So here's an example of a typical analytic application that's been built within the Lavastorm Analytics Engine. And just to give you an overview of the layout here, this is my application here. It consists of a number of controls, or what we call nodes, that we've dropped on our palette here and wired up by connecting them together. And each of these has a function that it provides, whether it's bringing in data, performing some statistical analysis or statistical function, manipulating the data in some way, even publishing the data. And as I string them together, I am flowing data through the system to get my results. The power is all captured in this library that supports this analytic application development. And within the library, I have controls for acquiring data, aggregating or summing that data, transforming that data. I have statistical functions, like I said. I can drop in visualizations, which are really powerful for helping me see the results, but also for sharing the results with others, interfaces to other systems, etc. Even publishing, so I can push the results back into databases or enterprise systems that I work with and share it with other people. In this case, this analytic application was developed so that I could investigate customer service issues, and this actually comes from a real experience we've had with a customer where they had a high incident rate of customer complaints or trouble tickets with one of their services, and it was a relatively new service, and they were trying to get to the bottom of why that service was generating more trouble tickets than was expected, and as a result it was affecting its profitability. So they wanted to design an analytic application that would allow them to investigate and uncover the root cause of those customer service issues. So to do so, we're bringing in very diverse data, and that's the first thing we want to point out, that the Lavastorm Analytics Engine allows you to bring in basically any type of structured data. So here we have orders coming in, and these are coming from 4 different databases and enterprise systems, extracts from enterprise systems, as well as some reference data. So these are text files that are coming into various codes we're going to use to link up with these data sources. So there's 6 data sources there on orders, and that's usually coming from more of a sales organization. I have installation information coming in. Again, 2 different sources there. One, a database that's my scheduling system where I schedule the installations. Another one which is actually from timesheets that come in from a third party. This particular customer uses a third party to do all of their service installations, and so the data is obviously stored in a very different location and collected in a very different way. So we're bringing in, again, a very dissimilar data source there. We're up to 8 data sources already. And then we're bringing in trouble ticket information, and trouble tickets are coming from the call center, and they're being brought in from a different system. And so right off the bat you see that it's a pretty complex challenge to bring together all of these different sources and get them to function together. But within the Lavastorm Analytics Engine, it's very simple to do that. Instead of having to design a model up front, we bring in the data, join it, and go. In fact, this is one of the major challenges that organizations face. And in this customer example, where it was a communications company, they actually had spent hundreds of hours, 400 hours, trying to bring together the data just so they could get a look at the problem, and were unable to do that. Whereas we were able to complete this entire application within just a couple of days using the Lavastorm Analytics Engine. So one thing that I want to look at and show you is how easy it is to bring in another data source, and also to use the visual model to do so. So the visual model gives me the opportunity to pinpoint where I want to modify my model. If my business changes, for instance, I can implement those changes very quickly. In this case, I mentioned that these trouble tickets are coming in from my call center. In fact, all of these nodes have really interesting business controls to them. So in this case, what I'm doing with trouble tickets is they're coming in from the call center, but I've got a nice node here that's providing a very useful function. So it's actually looking in a data directory. I just point it to a directory, and it's looking for a pattern of files that are getting deposited there. So in this case, it's voice something.csv. And it's looking for that pattern, and it's bringing them together. In this case, and the model is telling me information as I go here. So it's telling me that it found 2 files that match that pattern. Here they are. I can always drill down into the data. But at the high level, I'm getting information about how this is working. And if I had tried to do this alone using SQL, I would have probably had to have knitted these files together offline or using some other tool. But in here, this handles that kind of function automatically for me. So it brings them together, combines them into a single CSV. Again, the model is telling me that there's 125,000 records as a result after I bring these together. Again, I can drill down at any point and get all the detail of the data itself. So if I wanted to drill back into a model from a result and find out where things sort of developed, I can do that. Again, I can pinpoint those locations. Other controls that provide very useful information. I have a data analyzer here, which is actually exposing a lot of information about the data itself in summary form. So I can tell what fields there are, whether they're strings, integers. It gives me information about the length, the minimum and maximum length of those fields, how many nulls. So this is a great way for me to get an idea of the data quality without having to write any specialized code. It's all done here for me. Then I have additional functions that are taking off leading zeros and standardizing some of the numbers. So for instance, if I have systems that can't handle dashes because they're legacy systems, I can replace dashes with a blank space. So it's doing that kind of logic, and then I'm bringing in trouble ticket information, very detailed stuff, in this case from a different system, and this has all the time sheets and narrative information that I'm bringing together. And this is very valuable because a lot of times this provides the descriptive information that allows me to get to the root cause. It's not just the statistics, it's the information from customers themselves. So I can bring that together, again, analyze it, but join that together so I get a combined view of all the data. So now if I want to add a new data source because my business has changed and now I have added a self-service portal on the web for customers to enter their own trouble tickets, I can bring that in simply by duplicating this kind of logic. You know, this is very similar to the other call center, so all I have to do is copy and paste that logic that I want to duplicate. And in this case, I'm going to go back to that same directory, but I'm going to be looking for my internet tickets this time. And they have a different pattern. So I just type in that pattern that I expect. and really that's it. So now I have to reconnect it and do some things, but now I've got it looking for that pattern, and you see it ran successfully, and it's telling me again that I found 3 files that match that pattern. Again, if I drill down, there they are. It's also telling me some additional information, so I see this red X, which means something didn't go quite so well. And if I hover over it, I get some information here that says it expected to get 9 columns, but it got 10 columns. So this is an error that I'm familiar with. In fact, when I'm dealing with CSVs, this is a pretty common error because I might have a misplaced comma somewhere along the line. So in this case, what I can do is I can, again, this is sort of pre-built functionality. I can add a separate output pin here. We'll call this errors. And all of those other errors that didn't match the expected format will be automatically routed to this second pin. So when it ran through successfully, it's telling me it found 5 errors. 162,000 records went through successfully. So if I drill down into these 5 errors, yep, here they are. Again, they all have the same error string, and it even gives me the detail on the records. So I'm familiar with some of these problems that are kind of typical. So I've got a date and then a time and a comma in between, and that comma shouldn't be there. So it's giving me all the information I need to make any corrections. In fact, the model itself can do a lot more than simply the analytics. So I can actually take care of these problems and clean up these data quality issues using the logic that's provided in the library as well. So for instance, if I wanted to just simply email somebody that I've got some data quality issues, I can use send an email with a block. I can also, if I wanted to fix them here, I could actually bring in a filter. The filter node is the one that I use to transform the data. So I can bring in a filter node here, and I'm not going to do that, but maybe I would change the commas or fix the commas. I can even do things like set a threshold. So I might want to bring in a threshold here, like in fact if it's more than 10 records that have this issue, so I can go to my maximum record count. I can just say hit 10 here. Let me add a second pin, another pin on the output. So this threshold is looking if there's more than 10, then I can potentially fix them automatically or send the email. So simply by reconnecting the wires, I'm changing the logic of the application. And the other thing you notice is that I'm not doing any scripting here. It's really configuration. So really powerful tools here of all of the nodes that are in the library. Now I've got my data source coming in. I want to make sure that I bring all of this data together. So to do that, I have another node. It's the cat node, the concatenation node, and simply again bring them together and reconnect the wires. This one requires a little bit of configuration, but very, very simple for me to just unify those sources coming in. And then I simply rerun this part of the model. So I'm not having to go back and re-architect or rechange the overall data schema. I just brought in this information and joined it together, and now my model is updated. I've pinpointed that change, and I haven't had to go back and change any other part of my model. So very powerful stuff, and very fast to do that, and very logical as well. I mean, the other thing you notice is that I'm just thinking about the data itself. I'm not thinking about tables and other constructs that are artificial and sort of get in the way of my understanding the data itself. So I want to show you again some of the speed that takes place, and I'm building this up here so that I can actually go and investigate this particular problem that I've had around customer service, but I'm still making sure I have all the data at my disposal to do that. Again, these are other filter nodes that are transforming the data for me. This is timesheet data, so I'm adding work codes to that, and there's a whole series of work codes that I want to add for various functions that trying to break down the time that the installer spent at the customer site. I'm filtering out bad telephone numbers. I'm looking for telephone numbers that don't have 10 digits. I am zeroing in on the particular service that I'm having this customer service issue with, so I'm looking for only those installs that had that particular product code associated with them. And then I've made a decision in the past that I really want to look in more detailed fashion at the installations as opposed to repairs. So I've split these timesheets into two parts. For the installations, I'm doing some additional calculations, calculating the lunch time, the time spent right in front of the customer, and even adding a geographic reference based on the area code, so that if I wanted to analyze it by geography, I could do that. Repairs, I wasn't so interested originally, but what happens if my logic changes and I decide, you know what, I want to apply the same logic to the repair timesheets as well? Then again, it's very quick to do so. I can simply reconnect my nodes and make sure that all of these go through those steps now again, and then basically move the split to after that takes place. So and then make sure that I split after this. And so in just a matter of seconds, I have implemented new logic without having to wade through tables and queries and try to find my place, and that's really the power of the visual model that we're dealing with here. So I hope you're seeing how quickly you can do very interesting things. Now, in the case of I'm investigating this customer service issue, now I've got all my data together, so I'm going to start by drilling into these trouble tickets. And here, what we're seeing is the result of some discovery that I've already done and some analytic paths that I've already investigated. So in the case of what you're looking at here, you can view each one of these kind of paths as an investigation that I've done, and that's the real power of discovery itself, is that you start down with a hypothesis and investigate that hypothesis. Either you get to the end and you say it's not the one, or it is the one. If it isn't the one, you take another path, another hypothesis. Along the way, you might also discover things about the data that show you that a different path might be the real path to the root cause that you're trying to identify. So in this case, you can view each one of these as a various path that I've followed and gotten results from. So first I started looking at chronic trouble, and in that case, that means I was bringing in trouble ticket information, ultimately looking at the only the ones that had more than 2 trouble tickets initiated on those particular incidents. And when I get down to the end here, I actually looked at the data. I didn't really see anything that led me to think that was the root cause. And so I went back and actually did a little bit more. So I pulled off the data here, and I can pull off data from any point in the model. Again, that's the power of the visual model. Decided to join that trouble ticket information with order details, and matched it by telephone number, and then again filtered it down ultimately to chronic troubles. Again, that particular path didn't lead to anything, and so then I went on and said, well, maybe I should look at the various time points of when the trouble ticket came in after the installation. So I brought in information about the installation duration, and actually I pulled off from here after I have joined trouble tickets and output detail. I pulled off from here, joined that with this installation duration information, and then I've got various things set up here. So I'm looking at trouble tickets that happen early, like right off the bat within 7 days, ones that were 7 to 30 days, and ones that were after 30 days. And here I'm trying to look at those troubles with respect to the technicians that were involved. If I looked at some of those things, I might find that by technician, I have one technician that actually is generating more trouble tickets than others, but it doesn't look like a huge problem. So again, my logic might change along the way, and then my hypothesis might have been that it was early, but then when I see this data, I actually see that there are just as many trouble tickets that were entered 7 to 30 days as there were right off the bat. So let me investigate that path. And again, I can build it up the logic. I have full control to build up the logic with any block that I want. But I also, in this case, want to apply the same logic that I applied here to make to the tickets that came in 7 to 30 days. So let me just make sure this is wired correctly here. So I just copy and paste that logic, connect up the pins. Now I've got this data set going through and being joined with installation durations as well. And again, if I just run that portion of the model, I don't have to go back to the beginning. And immediately I'm getting results from this new query. But I haven't used any kind of query language. It's all been logically built up using these nodes. Again, I don't see anything that jumps out at me that indicates that it's the trouble by technician is showing the cause. So then I can take another path, and I'm actually bringing data off the details, order details with the original trouble ticket information, and now I'm going to join it up by equipment type, because that might be a cause. So I bring in that equipment type off from the installation forms. I filter it down into only the equipment types that I know are relevant to this particular service. Ultimately join it together, and then I do my filtering and bring it down. And now here I actually see something that's interesting, and I see that equipment 4, there's a very high percentage of this type of equipment leading to a trouble ticket than compared to the other ones. And so this is really my aha moment that I've discovered after a few different paths that I've gone through. So this is great. I think I'm getting to the root cause. Now if I want to share that with somebody, I can take advantage of some of our visualizations here, for instance, and I will bring in, maybe I'll create a bar chart that I can send to my manager to let him know that I think I've got the root cause, and I can just simply configure this visualization. And I simply right click on these to bring up the parameters that I can use. And I want to run this now. So again, visualizations I can put at any point here to get a better sense visually of how the data looks. In this case, I've decided that I want to do this for the result so that I can show that to people that I work with. It jumps out a little bit more here now that I've got that, and I can send that in email or other ways to the people that I want to share that with. So that's the power of discovery, and the power of this visual model, and the speed that the Lavastorm Analytics Engine brings allows me to continuously add new paths, change the model, change it quickly, change it on the fly without having to redo existing table structures that I would have had to in SQL, and a huge speed advantage. One of the more powerful things as well about this is that now I decide, you know what, that's a great result. I think I'm coming to the end here. I want to actually store that. So if I was using Access, for instance, I'm taking data out of Access, I can actually put it back into Access or whatever database that I'm using, my enterprise data warehouse. essentially creating a closed loop using the Lavastorm Analytics Engine, which is really valuable for IT people that want to make sure that the data is not taking a detour and becoming an island in itself. So I'm taking the data out, processing it, and now I can put it back into the data store that it is my data store of record. So I just need to configure this again. And I just need to create a couple of, fill in a couple of parameters. Again, I'm not having to write any scripts at all here. Run that. So I've got that going back into my Access database. If I just jump over to Access, I see a table that's been created there with the results. And again, everything is put back into the system. So one of the valuable parts of the Lavastorm Analytics Engine that shows is that this is entirely compatible with any IT or business intelligence infrastructure you might already have at your organization. So that ends the demonstration, and I just wanted to highlight some of the key points that we went over before. So again, what we've seen in the demonstration is the power that comes from the pre-built controls or nodes that we provide that are specifically designed for analytics. Other databases that you may use to tackle some of these problems don't have that same higher level tools for you to develop analytics very quickly. The visual model has a lot of power, and we don't want to underestimate that at all. Simply by having the visual model in front of me, I can understand my analytic, I can share that logic with others, I can communicate the logic to my superiors. It reduces all the work I have to do in terms of scripting, allows me to explore the data better, and it helps with sharing and productivity for my analytic team. And finally, enabled by that visual model, there's much greater speed and flexibility that comes with the Lavastorm Analytics Engine for exploration and discovery. And I tie a lot of that back to the fact that the Lavastorm Analytics Engine can process any data that you have without having to go back and create an overarching data model. So that means that I can add new data sources on the fly, I can make adjustments without having to go back to the beginning and reconstruct what I thought of. And the other thing about that is that to start my project, I don't have to do a lot of planning ahead of time and hope that things don't change. This is really encouraging for businesses that have experienced a lot of change. I can handle any change that gets thrown my way. So thank you very much for your time. I hope you learned a lot during this brief demonstration.